Welcome to the Johnson-Kendrow video hour. It will not be an hour, but I do have a confession. This is Miss Johnson. I'm by myself today. No Mrs. Kendrow, but she's going to be here in spirit. This is Mrs. Kendrow's high school graduation photo, and she still looks that good, doesn't she? All right, we're going to have to get through 5-1 without her. She's not able to record today. So we are doing 5-5. We're going to split this into two parts. So this is 5-5 part 1. And we're going to be talking about the rational root theorem and a couple other theorems as well. But just for part 1, we'll do the rational root theorem. We've been working with a lot of polynomials and finding the roots. Remember, when you're finding a root, you are simply finding the solution, or you're finding what x is equal to. And we're going to be able to find those using different methods today. So we need the rational root theorem because sometimes you're going to end up with polynomials that you cannot factor. Okay, I don't think that this cubic is factorable. There's no greatest common factor. It's not a special case. So we need something else that we can do. We cannot use quadratic formula because quadratic formula only works for quadratics. That would mean that my polynomial would have to be x to the second power and it's cubic. So that's not going to work either. And then, of course, you can guess who put this on there. Kendrow says you can't break your pencil. That's not going to solve your polynomial for you either. So we need something else. I like to call this the last resort method because it is pretty lengthy, but we do need it sometimes to be able to solve polynomials. So we're going to use that rational root theorem. What we do is we list the possible roots, and the possible roots are a list of, so now we're down here, factors of the last coefficient or the constant divided by the factors of the first coefficient. So for this whole problem here, I'm going to be referring to this polynomial. So we're focusing on the last number, which is 5 in this case, and then the first number, which is 2. Let me scroll down here. So the first is 2. And the last was 5. Also, I'm going to tell you it doesn't matter if they're positive or negative because we're going to put plus or minus on everything. So the factors of 2 are 1 and 2. You want to make a complete list. The factors of 5 are 1 and 5. So then we are going to list all of the possibilities. Now these are possible roots, they're not all roots. For the list, you're going to take the factors of the last number, so that would be the factors of the 5, and then divide them by the factors of the first number. And you need to be strategic when you do this, so you make sure you get all your possibilities. So I'm going to start with the 1. 1 is my first factor in the numerator, and I'm going to divide it by my other one. 1 over 1, that's just 1. Okay, by the way, you're going to put plus and minus in front of all of these. So plus and minus 1 is the first possibility. Then I'm going to move on. I'm going back to the 1, but this time I'm going to divide it by 2. So plus and minus 1/2. Not 2 over 1, 1 over 2. It's got to be factors of last divided by factors of first. Then I'm moving on. This time I'm going to use the 5. 5 divided by 1, that would be plus and minus 5. And then here's my last one, 5 divided by the 2, that's plus and minus 5/2. Now, if you think about this, I have 1, 2, 3, 4 possibilities, and they all have plus and minus in front of them. So technically, I have 8 possible rational roots. And my original polynomial, remember, was that 2x cubed. In fact, I'm going to write that down here. 2x cubed minus x squared plus 2x plus 5. This is a cubic function, so we know that this thing has a total of 3 roots. Not 8, has a total of 3. And it's possible that only one of them is going to be a rational root. So what we're going to do from there is test our list of possibilities. Our 8 possibilities, we're going to find out which of them are actually roots. So here are my steps. I'll drag this polynomial down here so we can see it when I scroll down. All right, you'll want to hit pause and copy down those steps. These are really important and helpful as we're going through these problems. So we're going to list the possibilities. We already did that. Then what we're going to do is start testing the possibilities. When you test these possibilities, you can do this one of 2 ways. I think the faster way is to do synthetic division. So you're going to take your root and you're going to put it in the press box. So for instance, if I want to test, I'm starting here, I'm going to test positive 1. I'm going to put that in the press box. Then I'm going to put the coefficients of my polynomial going across the top here. So 2, -1, 2, and 5. And I'm going to do synthetic division with this. So first step is to drop down the 2. Then we're going to multiply by 1. That's 2. add them together, we get 1. 1 times 1 is still 1. Add them together, we get a 3. 3 times 1 is 3. We add them together, we get 8. So what we're looking for here is a remainder of 0. If you do not get a remainder of 0, that means that this thing you just tested is not actually a root. So I tested positive 1, not a root. So then you got to move on. You got to go back and check something else. So I'm going to go back and redo this. I'm going to try negative 1 this time. 2, negative 1, 2, and 5. Do it all over again. Drop down the 2. 2 times negative 1 is negative 2. Add those together, I get negative 3. That would give me a 3, positive 3. Add them together, I get a 5. End up with a negative 5. Add them together and get 0. Yay, jump for joy when you get 1 to work. Okay, so what that means is negative 1 is one of the roots. It's one of our solutions of our equations. And technically, you have just now, since you did synthetic division, you have factored out that root. So if you look at what we're left with here, we're left with a polynomial, and it's got to have 1 degree less than what we started with. So technically, we have a quadratic, 2x squared minus 3x plus 5 equal to 0. I went through my steps here. I listed the possibilities. We tested. I used synthetic division. I'll talk about the plug-in in just a second. Some of you might prefer that. Now you're going to solve what you have left over. Your options to solve a quadratic are to factor it, use quadratic formula, or sometimes use square root method. We use square root method when we just have x squared and a number. Okay, I have a polynomial. I definitely don't have just x squared and a number, so I'm going to use quadratic formula here. Negative b plus or minus the square root of b squared minus 4 times, whoop, smart board. Now we're back. 4 times a times c, all divided by 2 times a. Simplifying underneath the radical to begin, negative 3 squared is 9. My sign's going to be a minus. I've got 8 times 5, so that's 40. All divided by 2 times 2, which is 4. Still going to work underneath the radical. 3 plus or minus. I have 9 minus 40, so that's negative 31 underneath there, all divided by 4. Next, I'm going to simplify my radical. It is an imaginary number because it's a square root of a negative. 31 is positive, so is prime, so we're just going to leave that in there. And this represents 2 solutions. So remember, the goal was to solve this polynomial and find the roots. There should be 3 total. So here are 2, 3 plus and minus I root 31 over 4, and you need a third. And that third is coming from the thing that worked when we did synthetic division. So negative 1 is the other possible root, is the actual root, I'm sorry. So 3 answers there. I want to take a moment and go back to my steps and point something else out. There is something else that we can do to get our testing here. I prefer synthetic division. The other thing you can do is plug in your roots into your polynomial. So what that means, for instance, if we were testing negative 1, you would go to this polynomial and you would substitute negative 1 for your x's. And again, you're looking for a 0. It is totally up to you how you want to test. Now, the reason I choose synthetic division over this way is because even if you get 1 to work, for instance, when you test this, this is going to work, this is going to be an actual root, you still have to do synthetic division. So I say, why not test with synthetic division to begin with? All right, that's a lot to remember. So we're going to do one more just so you guys can see another example. I have another cubic function. Instructions are to find the roots. How many will there be? Well, we're starting with a cubic, so there's going to be 3 total roots at the end, and that's something good to keep in mind. So we want to start by listing the possibilities. Remember, the way that you come up with the possibilities is by taking the last number, which is 2. The factors of 2 are 1 times 2. The first number is 15. There are more than one combination here, so it could be 1 times 15. It could also be 3 times 5. So when we make our list, remember you're going to put plus and minus in front of everything, and you're going to be strategic as you go through to find all the combinations. So I'm starting with 1. 1 divided by 1 is 1. Then I'm going to have to do 1 divided by 15. That's 1 over 15. Then I need to do 1 divided by 3. That's 1/3. And then my last one, using the 1, is 1 divided by 5, so 1/5. That took care of this. Now I got to go back and do it with the 2. So 2 divided by 1 is just 2. 2 divided by 15 is 2/15. 2 divided by 3 is next, so 2/3. And 2 divided by 5, so 2/5. So lots more possibilities, and I picked a problem like this on purpose because I wanted to show you how to work with more than one combination of factors here. So you got to make sure that you have a complete list. All right, so those represent the possibilities. Probably only one of them is actually a root. So from there, we're going to test using synthetic division. Okay, I'm going to try +1 to start. So I'm putting +1 in the press box. I'm going to list the coefficients right across, which I scrolled past this, 15, -32, +3, and 2. All right. So doing synthetic division with this, I'm going to drop down the first term. That's 15. 15 times 1 is 15 again. Add those together, we're going to get -17 times 1, that's -17. We get -14 times 1. I don't think that's going to work. Okay, there's no need to finish it if you're sure that's not going to work. All right, so let's try something else. How about we try, let's do +2. So dropping down the 15 to start. 15 times 2 will be 30. Add those together, so that's going to be -2. -2 times 2 is -4. Add those together, we get -1. And then -1 times 2 is -2. Add those together, and we get 0. Yay, jump for joy. Okay, so this is one of your roots. This is an actual root. And if this is test or quiz, maybe go down to the bottom and write that in your answer line so you don't forget. This leftover polynomial, we started with something that was x to the 3rd power. So therefore, 15x squared minus 2x minus 1 is a leftover quadratic. I am going to use quadratic formula to solve that. So my a value is the 15, my b value is -2, my c value is -1. I'm going to go over here and do that. X equals opposite of b, so 2 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Working underneath the radical, -2 squared is 4. Then we're going to have a +60, all divided by 2 times 15, so that's 30 on the bottom. Let me make some space here. Underneath the radical, I'm going to add those together. 2 plus or minus the square root of +64 over 30. Now, can you reduce that? Do you know the square root of 64? I think we do. I think it's 8. So now we are at 2 plus and minus 8 over 30. And because this is a real whole number there, it's not imaginary, it does not have a radical with it, we can continue on. 2 plus 8 over 30 and 2 minus 8 over 30. This is 10 over 30, which is 1/3. So that's another one of our solutions. And then 2 minus 8, that's -6 over 30. And that's -1/5. Now I want to point something out here, how this is different than our previous example. We still have 3 roots for our final answer. 2 is one of them. Remember, that's coming from here. And then the other 2, 1/3 and -1/5. So how do these differ then from the last example that we did? We did something and we ended up with an imaginary solution. So what's different is the fact that this quadratic that we ended up with was not factorable. So we had to use quadratic formula. The difference is here, if I would have tried to factor this quadratic using the 4-spot method, it would be factorable, and then you would just have to set those factors equal to 0. You're not wrong if you use quadratic formula like I did. I tend to go that way just because it will work for every quadratic that we have. But the fact that we got rational numbers at the end, that's why that worked out. Okay, and that was because we had a positive perfect square underneath the radical. One more thing I want to point out about this. These numbers, the 1/3 and the -1/5, They appeared in our possibility list. Okay, they were up here. So they were possible roots. In fact, if I would have put 1/3 in here to start, you would have still gotten a remainder of 0. You would have had a different quadratic to use in your quadratic formula, but you still would have gotten the same answers at the very end. I think I'm going to stop there. We have some more things that we can talk about when we get to class, how to deal with quartic functions when you're using rational root theorem, and then how to solve our square root method quadratics as well. So see you in class.